definitions as I start. Similar and congruent figures. Okay, just to make this simple with you, similar means same shape, same angle measurements, but not necessarily the same size. Okay, this can be thought of as shrinking something. So I've got a big triangle or rectangle and I shrink it down or blow it up. Those would be similar shapes. Okay, here's an example. This triangle is similar to this one. Okay, this one is smaller and twisted, but if I picked it up and drew it right next to the bigger one, you can see I just kind of rotated it, stood it up. These are similar. This shrunk down is this blown up is that, okay? Or maybe a rectangle, if I wanted to draw a rectangle. I've got this little guy here and that guy there. I twisted this one and blew it up or shrank it down, okay? That's what similar means. There is a sign that is oftentimes used, and that sign is this wavy line. Okay? That means similar. Okay? The other word I want to define for you today is congruent. Okay? That is all of the above and same size. Okay? Instead of saying congruent, you might think the term identical. Okay? So this guy is congruent to this guy. Okay? Which is also, by the way, congruent with this guy. I just twisted it. And that's fine. Okay? Because if I grab my ruler, I would find they're the same measurements with the same angles. Okay? I didn't talk much about the angles because that doesn't really come up too much, but the angles here, this is a right angle, that's a right angle, that's a right angle. These, all four, are right angles, therefore this has to have all four right angles. This angle is probably about 60 degrees. This angle, we're going to call it 30 degrees. And when you shrink it down, the angles still will have the same measurement, okay, in terms of degrees. These are all 90s over here. Okay. Congruent, identical, same shape, same size. So maybe I've got this pretty little triangle here, which is 2 by 2 by 2. If I twist it like this, assuming I drew them correctly, those are congruent as well. these are all the same as these. Okay? 60 degrees each angle. Since these are all squares, just this one got twisted, the angles are all 90s. Okay? I showed you the squiggle is the symbol above for similar. The symbol for congruent is a squiggle plus an equal sign. Okay? There's the shape for that. Similar looks like that. Now, notice that it took the congruent squiggle but added an equal sign. So something is congruent if it is similar and exactly the same. You guys realize that? So I can say these are similar. Sure they are. They have the same angles. But not only are they similar, they're also identical, which is why they are congruent. Okay? Let's get started on what the book says. The book gives us a little notebook thingy, and in it says properties of similar figures. Similar figures have matching lengths. Okay? Similar figures have matching their sides correspond to their bigger ones. So it sounds confusing, but it really isn't. If you look at the picture, I feel like the picture paints the words really well. Here's the little one. If I double the little one, I get 10. If I double the other one, 6 and 8. So whatever you do to increase or decrease, whether you double it, triple it, or divide it in half, divide it by 3, that's what you're going to do to the sides for the other sides, okay? Another way of saying that is the ratios of matching sides is the same. 4 to 8, that's a half, right? 3 to 6, is that also a half? How about 5 to 10? That's a half as well. Even if the shapes are not laid the same way, if you flip them so that they appear to be arranged the same way, you'll be able to figure out what matches with what. And that's where example 1 takes us. Okay? Example 1 says LMN is squiggle PQR. Does that mean similar or congruent? Similar. Okay. Triangle LMN is similar to triangle PQR. They've told us this. You can trust this. This is a given in the world of geometry, which you guys will be adventuring into soon. So knowing this, what side corresponds or matches with the other triangle's side? And in the same way, what side or what angle corresponds to the other triangle's matching angle? First of all, what I want to do is I want to draw my triangles, and I am terrible at matching or drawing them, but I'm going to do my best. So this is L, M, N. Okay? They have the other one drawn a little bit smaller, and it has the R here, the Q, and the P. Okay, this one is the bigger one. This one's a little bit smaller. I probably should have made it a lot bigger, but you get the idea. Okay, that one's bigger. If I take this and I rotate it 180 degrees, you will end up with this. Okay. Here's R. But if I rotate this 180 degrees, Q is here and P is right below it. Do you guys see how I just picked it up and flipped it over? Does everybody see what I'm talking about here? This is critical stuff, guys. Now, what side matches what side? Which is corresponds. What angle matches what angle? That means corresponds. All right, would you all agree with me that side LM matches side PQ? So side LM corresponds to side PQ. I'm not going to write corresponds to. I'm just going to use that. How about MN and QR? Don't those appear to match? Side MN corresponds to or is similar to side QR. How about this long side, LN and PQ? Side LN, side PQ. Notice that if I said this one first, you have to mention that one first when you're talking about the other one. PR would be better. Let's get it right. Yes. LN, PR. Thank you. Okay, that's the sides that correspond to the other guy. Okay, if I said on Justice, what corresponds to this? What's Justice going to point to? His nose. They're similar. They're not identical. Okay, what if I said this? Justice, what does that correspond to? Okay, these match. Even if Justice was laying on the floor in a completely different arrangement, you match head to head, nose to nose. You just have to identify what matches what in the shape. Okay? Angles. Angles. Angle L appears to correspond to angle P. Would you agree? How about angle M? What corresponds with M, class, on the other triangle? Q is right. Bravo. Last one. How about if I asked you what corresponds to R? What would you say? N. Okay? I like using different colors because I feel like it helps. All right. This way of describing stuff works with quadrilaterals, rectangles, triangles, doesn't matter. Okay? As long as it is a polygon. Okay. So given quadrilateral ABCD is similar to quadrilateral WXYZ. Okay? They are telling us that these things are similar. So I'm going to draw these. And I'm not going to do a good job. Sorry. This one is a little bit bigger. Blown up version of this one, okay? And they are labeled A, B, C, D. Now, A corresponds to W. Do you want to know how I know that? Because the order they write them, if they tell you it's congruent or similar, the order they write them matches the other one. So if this is A, this is B, this is C, this is D, then I am going to guess that the corresponding sides are, oops, I changed my color, W, X, Y, and Z. How do I know that? Because if I flip it over, which I'm going to do, you will see that the A corresponds with the W, which is now here. That makes that the X. That makes that the Z. And that makes that the Y. Do you guys see how I just flipped it? I just flipped it over. Okay? And I ended up with that. Now that you've done that, you could probably see the angles. Angle A corresponds with angle W. What does D seem to match, class? D matches what? Z. Once you flip it over, it makes it a whole lot clearer. D and Z. Okay, you've got to label it correctly. I'm sure you could see that C corresponds to Y and B corresponds to X, right? Let's make sure we understand this by identifying some sides. What if I said side CB? What will you say it matches in the other quadrilateral? Side CB. Ben, what would you say? Nope. You're naming the right side, but you're saying it wrong. I said CB. So what must you say? YX. You have to say it in the correct order. Okay? What if I say to you BA? I'm saying it that way. Side BA. What does side BA correspond with? Well, I went from right to left, which means I'm going to have to go from right to left in the other shape. So what would you say, Kat? What does it correspond with? BA. BA. She's right. She said it in the proper order, too. XW. Okay? All right, that was the checkpoint. Okay, moving on. Ratio of corresponding side lengths. Ratio of corresponding side lengths. You guys learned about ratios already, and that is matching fractions, right? Corresponding side. Okay, ratio of corresponding sides. Okay, so we've already said that CB corresponds to YX, right? CB corresponds to YX, matches, okay? Is similar to, is another way of saying that. Well, given what they've drawn for us, they've got quadrilateral ABCD, which they've drawn on its side, but I'm going to flip, okay? I'm just going to flip it because I don't have time to fool around here. There's ABCD. ABCD corresponds to, or is similar to, JKLM. Okay, trust me, they match. Not very good at drawing it. JKLM. Do you guys see how I kind of took this little one and I flipped it? Okay. They give us lengths. They've got 8, 2, 8, 4. And in the bigger one, they've got 6, 12, 3, 12. Okay? Write a ratio comparing lengths of a pair of corresponding sides. All right. They compared AB with JK because AB corresponds to JK. AB, JK. What's the length of AB, folks? 8. What is the length of JK? Anybody know what the length of JK is? It's 12. Let's reduce it by a factor of 4, and you end up with 3 to 4. 3 to 4. What if I did a different pair of sides? What if I did, no, 2 to 4. 4 goes into that twice, 4 goes into that 3 times. Could I reduce it? What am I doing wrong here? 8 to 12. 2 goes into that twice, 2 goes into that 3 times. Good grief, guys. Sorry. I'm rushing and I'm making silly mistakes. Okay, 2/3. What if I did a different set of sides? What if I did AD over JM? You don't have to choose what I chose. What if you did AD over JM? What's the measurements of AD? 4. What's the measurements of JM? Tell me. What does that reduce to? 2/3. Is that the same as this? It sure is. Okay?